So for our first example, we have that an economist wants to determine whether there is a linear relationship between a company's gross domestic product, GDP, and CO2, carbon dioxide emissions. The data are shown in the table, and we want to display the data in a scatter plot and describe the type of correlation, assuming that it exists. So, what we can do with a data set like this in order to make a scatter plot is go through point by point. So, for example, in that first one, the X value, $1.8 trillion, can correspond to an ordered pair 1.8, comma, 604.4 for the 604.4 million metric tons of CO2 emissions, which seems like a lot to me, but I don't actually know for reference if that is a lot. I'll have to look that up later. But doing that piece by piece, not the most efficient use of my time, and it certainly wouldn't be the most efficient use of your time to watch me do it. Really, what you're going to want to do here is get comfortable plugging each of these into the table in your calculator and following through on the steps in there to have that output. It's kind of a picky process. Do a little careful with where things go in to make it come out the right way and make it look nice. But if you do that, if you go through bit by bit, you should get a graph, a scatter plot that looks something like so. Now, looking at this scatter plot, we can see that, like I talked about, it's not exactly a perfect relationship. In the reality of the real world, in the reality of actual data sets, you basically never get perfect correlation. And we'll talk about exactly what that is when we see something later in this section and further on in the chapter, that there's always a little bit of room for error, a little bit of room for variability, but that's a pretty good pattern. It's actually about as good as we're going to get. And we're going to spend a lot more time with this data set in particular just because it's convenient for me to use the same one repeatedly. But we're going to see as we go through that actually is pretty strong correlation. And in particular, that is fairly strong positive linear correlation indicating the relationship between a country's GDP and their CO2 emissions. That is, as GDP goes up, it would appear that CO2 emissions do as well, albeit there are some things in that data set that might skew that a little bit, and we'll have to talk about exactly what that connection may or may not mean, but thinking about it, it does make sense with the way that how a lot of our economic decisions are influenced by fossil fuels and how many fossil fuels developed nations use. It doesn't seem unreasonable that the wealthier nations would use more CO2. So that connection is illustrated somewhat by our scatter plot, and we'll see it in more detail, as we go further, and it makes some logical sense to begin with. On the other hand, for our second example, we have that a student conducts a study to determine whether there is a linear relationship between the number of hours the student exercises each week and their GPA. The data is shown below. Display the data in a scatter plot and describe the type of correlation, should there be a meaningful relationship. So in the same way, we can ask our calculator to do this work for us or get it ourselves. If you want to do it by hand, by all means, you're welcome to. It's maybe a good way to get used to how these things come together. But long and short of it is you should get a picture of something like this, where, at best, there might be a bit of a flat connection there, but it's a bit jumpy. It doesn't seem like there's a whole lot of useful connection we can ascertain there, and it kind of makes sense if you think about it. If you're exercising, it does mean that you don't spend as much time studying, but for some people, getting exercise helps them focus, and it's not always like that. Even if it was, you're probably not spending that much time exercising. It's not the sort of thing that most people are spending more than a few hours a week on, so you really do have a lot of other time that you may or may not be using effectively. So it fits, looking at that data set and probably your heuristic sense of what should happen, that in some sense there doesn't really appear to be a meaningful correlation relationship. Maybe there is one if we dig a little bit deeper, but as far as we can tell, or maybe there is one that's a little bit more advanced than a linear relationship, but as far as we can tell, there doesn't appear to be a connection. And that's the sort of thing that'll happen a lot. You can pair up any set of data, any sets of data, but many of those pairs they're just not going to mean anything. One's not going to affect the other, one's not going to cause the other. They're completely independent things a lot of the time. Like here, as this data seems to indicate that we don't have much going on between them. That said, the next thing we're going to look at is an idea called the correlation coefficient. We're going to be able to, in a bit more detail, actually describe whether or not that relationship is or should be there, even if it doesn't bear out immediately. This we're doing next.